Om Sri Sai Ram. Hearty welcome to Sri Sathya Loka Seva Gurukulam. Welcome to the science chemistry class, the continuation of the periodic classification of elements, what you have studied in the previous class. I think all of you are ready with the textbook to see the contents, especially the periodic table, and let us just recall what we have studied in the previous class. The first one was about the structure of atoms and their electronic configuration. We have seen in the previous lesson, that all matter is made up of small particles called atoms. Later on, it was the discovery of the electrons said that the electrons occupy different positions like K, L, M, N, O, P, Q. Is it not? And we call it as configuration. And then we also study the importance of classification. We refer to the medical shop. Just imagine if all the medicines are put helter-skelter, how difficult it is to locate it and give it, right? Even in the shops also, if all soaps, paste, brush, everything put in a junk, it's very difficult to locate it, right? Instead of that, if you classify it neatly, it saves time also, it saves energy also, it saves money also. Is it not? That's why similarly elements also, to study the properties, the nature and so on, they have to be classified. Then there were scientists like Dobeiner who made the first attempt in classifying the elements. He called it as Dobeiner's triads. Triads means he took 3 elements. He took 3 elements as grouping, and then that was the first element, attempt he made. Then came new lands. The defects in the Dobeiner's was eradicated. In the new land's law of octaves, because Dobeiner could not classify all the elements discovered that time, about 40. He could do only 3 sets. Then came Newland's law of octaves, who on the basis of the octaves, or what you call as Sapta Swaras in Indian classical music, the 8th swara resembled with first. So also in Western music, the first swara resembled with the 8th. So that was the basis for his law of octaves, who said that the first element, when the elements are arranged in the increasing order of atomic masses, the property of the first element resembled with the property of the 8th element. That is what is called as Newland's law of octaves. Even Newland also could not classify all the elements at that time. And then came Mendeleev, who gave a very beautiful idea of classifying the 63 known elements. Then he gave face for all the 63 elements. Not only that, he predicted the properties of some more elements. He leaves some blank space. That is another achievement of Mendeleev. which are going to study a short after this. So before we come to today's topic, we will see the answers for the home assignment. First question was, what was the earliest classification of elements? The earliest attempt to classify elements was resulted in grouping the then known elements as metals and non-metals. The first classification. But when elements like silicon, germanium were discovered, they are known as metalloids, which have both the properties of metals and non-metals. Then a scientific classification was needed, and hence the other discoveries were made, as the Dobrynin's law of triads to start with. Here is a question: state Dobrynin's law of triads. Elements A, B and C constitute a Dobrynin's triad. Why it is called triad? Because we are taking sets of 3. In this, atomic mass of A is 20 and C is 40. Of course, you write that as U, 20U and 40U. U is nothing but atomic mass unit. What is the atomic mass of B? So, answer is, Dobrynin showed that when 3 elements in a triad were written in increasing order of atomic masses, the atomic mass of the middle element is roughly the average of the atomic masses of the other 2 elements. So, when you take 3 elements A, B, C, atomic mass of element B is equal to atomic mass of A plus atomic mass of C by 2, means average. So, A is 20, B is C is 40. So, 20 plus 40 is 60 by 2, that is 60 by 2 is 30. So much of atomic mass units, 30U. Okay, I think you understood now. That is a Dobrynin's law of triads. And next question, which property of atom was used by Mendeleev to classify the elements? He took atomic mass. What is atomic mass? The sum of the protons and neutrons is called as atomic mass, and the unit they use is atomic mass unit and AMU, shortly called as U. Okay, that was the basis. What are the limitations of Newland's law of octaves? And Newland's law of octaves, octave means 8, not applicable to elements of atomic masses higher than 40U, up to 40 only. So, the remaining 20 elements known at that time could not be classified because they did not come into the way. For example, if you take noble gases, the first element behaved like 9th element, not 8th. So, this Newland's law of octave could not be used there. So, that was the limitation. Another limitation is with noble gases like argon, neon, etc. It is found that the 9th element had the properties of the first one and not the 8th element. This resulted in the rejection of the very idea of octaves. So, idea of octaves changed because in the case of noble gases, the first element behaved like a 9th element. So, the law of octaves was not successful because it was limited. Then came Mendeleev's periodic table. So note this table as we have seen in the last class. That is a topic to be learned today. We have seen that he arranged the first point, all the elements in the increasing order of atomic masses. See, in the PT class, what your PT sir do? He will call all the boys or girls to come in line outside. And when you come in line, he will show like this, shortest to the right and tallest to the left. That is one way. It is called increasing order of heights. Are you following? So in so many cases we find some beautiful patterns. So here also you can see a beautiful pattern. He used the principle of increasing order of atomic masses. Secondly, he used this RO and RH. RO means he predicted that most of the metals or nonmetals combined with oxygen forming an oxide. So we call it as RO, some oxide. Similarly, if not oxygen, hydrogen will react. For example, carbon reacts with oxygen to form carbon dioxide. And it also acts with the hydrogen to form methane. So instead of C, they use the RO. Instead of C here, we use RH. That is one speciality of this. And here, the vertical columns are called as groups. And the horizontal one are called as periods. So, how many groups are there? You have 1, 2, 3, 4, 5, 6, 7, 8. So, there are 8 groups. Okay. And each group is divided into 2 parts, A and B, depending on the properties. So, the 8th group are called as transition series. They are kept separately here because they have got properties in a horizontal way. They resemble horizontally. For example, iron, cobalt, nickel, they are the magnetic substances, or magnets can be prepared out of it. And that's why the special property of them, they are separately called as transition series. And one more feature is 4th, 5th, 6th period. There are 2 groups again, 2 series. One is the top series here, and bottom there is one more series. So these 4, 5, 6. There is some resemblance between them. That is another feature of this Mendeleev's periodic table. And most interesting point is he left some gaps. For example, left gap here. He could not predict, or he said some more elements could be discovered in the gaps depending on the property. So, for example, he left some gap here, and he could not name it, or he could not predict the element. He left for the next scientist or next younger generation to discover. So, that is a speciality of this, leaving blank spaces, which made the scientists and other youngsters to discover more and more elements. Because in his time it was only 63 elements were there, and let us just revise that. Elements are arranged in the rows and columns. The vertical rows are called as groups. Horizontal one are called as periods. So, periods, there are 1 to 6th period. 4th and 5th, 6th, 4, 5, 6 periods have 2 series of elements. I just now shown it. Okay. and properties elements in a given period show regular gradation from left to right. So, properties, there is a slow increase in that property, their metallic property or non-metallic property, etc. Vertical columns represent it are called as groups. There are eight groups. There are 8 groups and they are numbered from 1 to 8. I have just shown it now. And in every group you find A, B except in 8th group. Okay. And groups 1 to 7 are further divided into A and B subgroups. However, 8th group contains 3 elements in each of the 3 periods. That is another feature or another speciality of this Mendeleev's periodic table. All the elements present in a particular group are chemically similar in nature. They also show a regular gradation in the physical and chemical properties from top to bottom. And one thing I forgot to tell you in the beginning, that Mendeleev is a Russian scientist and he was inspired by his mother. See, the parents are very important. If the parents are good in nature, children also will be good. They learn so many good things from the parents. So, Mendeleev is one such. His mother prompted him to do lot of innovations, innovative ideas, okay, experiments and so on. She encouraged him in all the fields. She also travelled with him for all many places, many laboratories and so on. And she was a very inspiring soul as far as Mendeleev is concerned. So he says, whatever discovery I have made, all this credit should go to my mother. In our Indian philosophy also, we give top priority to mother. We say it as Matru Devo Bhava. Means what? Mother is like God. Pitru Devo Bhava means father is like God. Athiti Devo Bhava means guests are like God. Acharya Devo Bhava, teachers or gurus are like God, though they should be treated well. He also treated his mother with all respects. Even mother also encouraged him at all levels. So, a lion cub is born only in the lioness. That means, as are the parents, so are the children. Shivaji, Vivekananda, Shankaracharya, Baba and all these great men, they had their parents also like that. They gave all encouragement. They were noble in their behaviors. By seeing the goodness, the behaviors of elders, children also learn their goodness. So even Mendeleev also learned that goodness, and that was an inspiration for him to discover this new idea. All the elements present in a particular group are chemically similar. First group, if we say, all have got similarity in the property, like metals, non-metals and so on. They also show regular gradation in their physical and chemical properties. Gradation means change from top to bottom. So these are some of the features of that, and let us just recall the merits of Mendeleev's periodic table. First one is classification of all elements. So all the 63 elements discovered at that time were classified by Mendeleev in a systematic way. That is his speciality. Correction of atomic masses. Atomic masses of elements like beryllium, gold, indium, etc. were corrected based on the position in the periodic table. For example, indium has been assigned an atomic mass of 76 and valency of 2. On the basis of its position in the periodic table, Mendeleev predicted its atomic mass to be 113.1 and its valency to be 3. So today it is believed we have mass number 114.82, almost same, and valency is 3. This is a very special contribution. He predicted the certain elements to be filled up in the periodic table. So that is a very unique feature of Mendeleev's periodic table. So that is what I just now telling you, the blank space. Mendeleev, while arranging the elements in the increasing order of atomic masses, he could not find an element with the expected property. So he left gaps to find out or discover new elements. For example, elements like radium, polonium, actinium, etc. They are all radioactive elements discovered later, and the radioactive elements discovered in the laboratories, and it was Mendeleev who gave this idea of predicting. He predicted the existence of unknown element for the vacant space below silicon and thus belonging to the same group of 4th B. Under 4th B he left some gap, and he called it as Eka silicon, meaning one position below silicon. Later it was named as germanium, which had remarkably similar properties. Silicon, germanium, etc. are called metalloids, which have property of both metals and non-metals. So he called it as Eka silicon. This Eka, that is a Sanskrit word, number. Eka means 1, Dve means 2, Trini means 3, Chatvari means 4, like that. That is Sanskrit numbers. So he called that you have to discover an element called Eka silicon, means having property of similar to that of silicon and should be kept below this silicon, and that is why the name Eka silicon, Eka aluminum, Eka boron, and so on. Then they named it as germanium, and even the atomic mass also was approximately predicted, and that is a very good achievement as far as the Mendeleev's periodic table is concerned. Similarly, you have Eka boron. Later on it was called as scandium. Eka aluminum, later on it is called as gallium, are two more examples of unknown elements predicted by Mendeleev. So Eka boron, he left a gap below boron. Similarly, Eka aluminum, below aluminum a gap was left. Then it was discovered later, they named it as scandium, and Eka aluminum was named it as gallium. So that is how he inspired or he encouraged the budding scientist to discover more and more. And one more feature or one more merit of the Mendeleev periodic table is that valency of elements. Mendeleev's classification helped in the understanding the valency. What is valency? Valency is nothing but the combining capacity. Combining capacity of an element is called as valency. And how do you measure it? How do you get it? That is by seeing the number of valence electrons. Electrons given out or electrons taken in by an atom of an element is called as valency. For example, valency of sodium is 1. Lithium, sodium, potassium all are 1. Hydrogen also. They are all placed in the same group because they give out an electron during chemical reactions. Similarly, chlorine, bromine, fluorine, etc. they take in 1 electron. Therefore, their valency also is 1. So, the valency also can be predicted by the Mendeleev's periodic table. And again, there are some defects in the Mendeleev's periodic table. And what are the defects? Position of hydrogen. It was kept in first A. With metals they are kept. With the alkali metals. Actually, hydrogen is not a metal. Actually, it should have kept under halogens. But it is electropositive in nature, gives out electron. Therefore, it is kept in the first A group. But anyway, it is very ambiguous. Means the position of hydrogen is not clear in the Mendeleev's periodic table. And Mendeleev's periodic table did not provide any space for different isotopes. What do you mean isotopes? Isotope means iso means same. Tope means position. Where position? In the periodic table. So, elements having same position in the periodic table are called as isotopes. For example, we have carbon has 2 isotopes, famous one, still there are 2 more. C12 and C14, what you call it. There is no separate place for them. They are put together. Even hydrogen also 3 isotopes called as H1, H2, H3. These are the 3 isotopes of hydrogen. But all of them put together. So, there is no place for isotopes. That is another what do you call it, a defects of the Mendeleev's periodic table. And one more thing is, at some places an element with greater atomic mass had been placed before an element with lower atomic mass. Means cobalt is 58.9. It is kept before nickel 58.7. You can check in your book. Actually, this should have come first, then this. But reverse is true. So, that is another defects of the Mendeleev's periodic table. Actually, his law says when elements are arranged in increasing order of atomic masses, but here it is decreasing. So, his law is not in line with this. So, that is another defect of the Mendeleev's periodic table. And elements such as copper and silver have no resemblance with alkali metals, but they are put under alkali metals. So, alkali metal means what? Lithium, sodium, etc. Their property is different and these properties are different. And one more defect is elements which are chemically similar such as gold, platinum, etc. They are kept separately, separate groups. You can check in your book. Gold and silver are kept separately, even though they are both shining metals used in ornaments. They are kept separately. That is another defect of the Mendeleev's periodic table. So, when all the defects are known, so what is the solution? You must think of some other new way of presenting the elements, is it not? So, let us see in the next class about a modern periodic table, how it is made and how it is on which basis it is made, and all we will see in the next class. Okay. Before we close, let us see some home assignment. First question, Mendeleev's periodic classification state whether chemically similar elements are placed in a group or in a period. Mendeleev's second question, Mendeleev's periodic table had some blank spaces. What do they signify? Third, give any two achievements of the Mendeleev's periodic classification. Fourth, use Mendeleev's periodic table to predict the formula for the oxides of the following: potassium, carbon, aluminum, silicon, sodium. You must write the names of the oxides or write the formulas. So, these are some of the home assignment. I hope all of you come prepared with that. Next class. Thank you. Sai Ram.